Good day, everyone. How's it, grade 12s? I hope you're good, man. Today we are going to be specifically looking at stating Newton's laws. Okay, please, guys, please don't waste your marks during your examinations. Okay, these are just free marks, so it's a must for you, and it's advisable for you to know and understand um Newton's laws. Okay, yes. More especially in stating them. Okay, as you can see here, for instance, in each and every paper, even the paper that you are going to write, the fact that it's only the fact that I don't know which Newton's law that is going to come out, but I'm sure there will be a Newton's law that is going to come out on question 2. Okay, and the very first question is going to say state Newton's law. Okay, Newton's second law, Newton's first law, Newton's third law. Okay, I'm 100% sure. So today's lesson, it's all about some kind of a revision. Yes. So as you can see here, we have 2014 November final examinations that were written in 2014. As you can see here, question 2, question 2.1, which says state Newton's second law of motion in words. Okay, so we're going to be looking at that today. Yes. So again, I'm saying it's going to come out. Let's go look at 2016. See, this is 2016 that was set by Department of Education final examinations. The very first question 2.1 says, and the question 2 says state Newton's first law in words. So again, I'm saying it's going to come out during examinations, guys. Please pay some attention for today's lesson. Okay, this is 2017 again. 2017 2.1.1, very first question, they said state Newton's first law in words. Okay, let's go to 2018. This is 2018. Very first question, question 2, they said state Newton's second law in words. Let's move to 2019. Yes, the last example of the question paper that I brought to you guys. So 2019 says, the very first question, question 2 says state Newton's second law in words. Okay, so guys, our fundamental lesson today will be about stating Newton's laws. Okay, Newton's first law, Newton's second law, and Newton's third law, so that you can know by your mind. Okay, yes, they must stay in your mind, guys. Okay, yes, it's a must, so that you don't waste that 2 marks. Okay, as you can see, 2 marks. Please don't waste that 2 marks. Okay, please don't waste that 2 marks. It's a free mark. Okay, because it's obvious that a question that will say state Newton's second law, Newton's first law, Newton's third law will come out, but mostly, as you can see here, it's always Newton's second law. Okay, yes, so meaning that you should and you must know Newton's second law, Newton's first law, and an end. Okay, more especially in stating them. Okay, but today we're going to be critical looking at stating Newton's laws. Let's go. Okay, so let's stating Newton's laws. Okay, I made some little notes for you guys. It's going to be a very quick it's going to be a very quick lesson, yes. So it's a lesson revision. Okay, yes, you are revising for that 2 marks. Okay, so that at least you grab some marks, free marks. Please don't leave free marks behind, guys. Okay, so Newton's first law. Let's start with Newton's first law. Newton's first law, if they say state Newton's first law, and your question 2 or your whole question is looking at Newton's first law, the very first question you say state Newton's first law. So if they say so, please say Newton's first law states that a body will remain in its state of rest or motion at a constant velocity unless a resultant or a net force acts on it. Meaning that, or we can say, Newton's first law states that every body continues in its state of rest or of uniform motion in a straight line unless a resultant force or a net force acts on it. Okay, yes. So let's go and look how they give you marks when stating these laws. Okay, yes. So when you're stating very first law, Newton's first law states that a body will remain in its state of rest or motion at a constant velocity. Okay, yes. So meaning that that's your 1 mark. Newton's first law says that a body will remain in its state of rest or motion. Okay, that's your 1 mark at a constant velocity unless, okay, a resultant or net force acts on it. That's your 2 marks. Then they give you your 2 marks. 2 marks, or Newton's first law states that everybody continues in its state of rest or of uniform motion. Okay, yes, that's your 1 mark in a straight line unless a resultant net force acts on it. That's your 2 marks. Okay, please fully explain or fully state your Newton's laws. Okay, let's go and discuss fundamental about this very first law. Okay, yes, let's just be quick. This basically means that, for example, if ever you're in a car speed, you are traveling the same as the car speed. Okay, yes, let's say this is our car. I'm just going to draw here. Okay, this is your car and you are inside. Okay, this is your car moving this way at a constant velocity, okay, or in its uniform motion in a straight line. So a car will always moving. Okay, yes, as you are the passenger here, you're moving the same speed as a car. Okay, yes, so it will continue moving in its uniform motion unless there's a net force acts on it. Okay, a net force might be the driver applying brakes. If ever the driver is applying brakes, you will see that even the passengers will want to continue moving forward. Okay, yes, until safety belt helps. Okay, yes, that's when safety belts are vital, okay, to wear, because you will always move forward at the speed of the car. Okay, because it's only the car that apply the brakes. As you are the passenger person, you don't have brakes. Okay, yes, so you will want to continue moving forward. That's also called, or that's also contribute inertia. Okay, yes, so that's how it goes for the very first law, Newton's first law. Please understand it. Please be able to state Newton's first law. Okay, let's move to Newton's second law. Okay, so Newton's second law states that um, when A non-zero, which is a net force, okay, a force that acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the force and inversely proportional to the mass of an object. Okay, that's most popular one, that's most usable one, that's most easy to understand one. Okay, yes, in terms of stating Newton's second law. Okay, or you can say the resultant or net force acting on an object is equal to the rate of change of momentum of the object in the direction of the resultant or net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Okay, let's go. Let's start by giving marks. Okay, so let me first go through explaining, or let me just give you marks. Okay, Newton's, how they give you marks when stating Newton's second law. And this is the most popular one that usually comes out during examinations. Newton's second law states that when a net force X on an object, the object will accelerate in the direction of the force, or of the net force, with an acceleration that is direct proportional. Okay, so that's your 1 mark. Okay, we stop there. The second law states that when a resultant or a net force X on an object, the object will accelerate in direction of the net force. Okay, yes, that's your 1 mark, with an acceleration that is directly proportional to the force, to the net force, and inversely proportional to the mass of an object. Inversely proportional to the mass of it, that's 2 marks. Okay, yes. So ending there on the net force, that's your 1 mark. Continuing with the acceleration that is directly proportional to the mass of an object and inversely proportional to the mass of an object, that's other 1 mark equals to 2 marks. Okay, or you can say the net force acting on an object is equal to the rate of change of momentum of the object in the direction of the net force. That's your 1 mark. That's your 1 mark. Acceleration is directly proportional to the net force and inversely proportional to the mass of an object. That's your 1 mark again, which is equal to your 2 marks. Okay, 2 marks. Okay, that's how it goes. So this basically means that okay, let me make an example of this 50 kg block that we're going to have here. Let's have 50 kg block. Okay, let's have 50 kg block. Let's have this 50 kg box. Okay, let's say it's a box. Okay, this 50 kg block it's here, this surface. Okay, yes, so this 50 kg block, it's going to stay there until a force is applied. Okay, a net force. Okay, a non-zero force. So let's say a force of 100 newtons was applied by you, okay, in this box, in terms of pushing it. Okay, yes, 100 newtons was applied to this box. So as you can see that the arrow of the force, of the net force, is pointing that way. Okay, yes, pointing that way, meaning that the box will also going to accelerate that way. Okay, yes, so that's how it goes for the second law. So meaning that the object will accelerate in direction of the net force. Also, you can push the box to move this side. Okay, this side, but you can push a box to move, you can push a box this side. Okay, but move this side, no. Okay, it's going to accelerate in the direction of the net force. Okay, in the same direction that you are pushing it. Okay, that's how it goes. So this basically means that the net force, okay, where our formula comes from, F net is equals to ma, then the acceleration is directly proportional to the net force. Okay, to the net force. Okay, to the net force. And this acceleration is also inversely proportional to the mass of this object, which is 50 kg block. Okay, inversely proportional. That's how it goes. So the graph will go like this. Okay, in the y-axis we will have your acceleration, in your x-axis you're going to have your net force. Okay, net force. Also for this one, acceleration is inversely proportional to the mass of an object. In the x-axis you're going to have your mass. Okay, 1 over m which is inversely proportional to the acceleration. The acceleration is inversely proportional to the mass of an object. Okay, that's how it goes for the second law. Okay, yes. So please don't waste these marks, guys. Okay, please do understand Newton's second law. Okay, in terms of stating them. Okay, that's how it goes. Okay, now let's move to Newton's third law, stating Newton's third law. Newton's third law states that if an object A exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. Okay, this is always used by example of the fact that Earth is pulling you downwards. Okay, yes. Also, you are pulling Earth upwards. What does this mean? Okay, yes. So let's start by giving marks, showing you how they are going to give you marks so that you fully explain and you fully state these laws. So Newton's third law states that if an object A exerts a force on object B, then object B must exert an equal force of magnitude and opposite direction back on object. So it's a very first mark. Newton's law says that if an object exerts a force on object B, then object B must exert a force of equal magnitude and opposite direction back on object A. That's your 2 marks. Because you do understand that there are two different objects that are acting there. Okay, yes. So let me use an example of Earth. Okay, so this is the Earth surface. Okay, so this is the Earth surface. So this is you. This is you. You are not flying. You are just rigidly staying on the ground. So this is you. Okay, this is you. So you are pulled by the Earth. Okay, yes, because you know that there's also Fg, which is gravitational forces acting downwards on you. Okay, yes, but I don't want to speak more about that because we are now focusing on stating laws. Okay, but creating an understanding to you. Okay, yes. So this is you. Okay, pulled by the Earth. Okay, yes, to be on the ground. Why don't you go underground? Because there's also, you are also I can say you are also applying the very same force, okay, of equal magnitude, okay, to the Earth. Okay, yes, meaning that you are also pulling Earth upwards. Okay, yes, with an equal force. Let's say that was 200 newtons. Okay, yes, that was 200 newtons. Also, Earth was pulling you by 200 newtons. Also, you are going to pull up Earth by 200 newtons. Equal magnitude of the force that is going to be opposite. Okay, in the opposite direction. As you can see that your force that you are going to apply on Earth is in the opposite direction as the Earth as the force that Earth is applying on you. Okay, yes. So this is going to be equals to 0 newtons. Okay, yes. So your net force is equal to 0 newton in this phenomenon, meaning that you are going to be stable. You are not going to fly. You are not going to dig underground. Okay, yes, that's how it goes. Yes. So yes, I think that's how it goes, guys. So please know how to state Newton's laws. Okay, yes. So as you can see that I gave you some understanding in terms of stating Newton's laws and so on, more especially Newton's second law. Okay, that's how it goes, guys. I think that's the end of our lesson for the day. Please don't forget to subscribe. Those who haven't subscribed, please, my love the metric lens. um See you in the next following video.